What's up, Internet? It is I again, that guy again, and today I'm on the third revision of Block Game, and yeah, I've remade it from scratch a couple times, but this time the thing that I'm really proud of is the fucking movement. Like, dude, it's so fluid. You can move the camera and move, and like when I move forward, it's actually moving forward projected based on the camera, like where the camera's at. And so it's pretty sick. It's pretty sick. And I got all the basic features, interactable objects, doors locked from the other side, because this is the other side and it's got a lock on there. And if we go to unlock it, you need a key to unlock it. Womp womp, right? But there's a key right there. So boom, lock falls off, door be openable, other door be openable, just like that, right? So same shit as before. But now to get into the code a little bit. So there are 3 files that are actually important for the movement, and I have movemented them all around. So we're going to fix some things. Sorry, I got a lot of scripts in here, a lot of fun scripts. The 3 that are important for movement though, right, are movement controller, animated controller, which is a type of movement controller, right, and playable controller, which is a type of animated controller. And honestly, I was kind of experimenting when I did this because, like, essentially what it is, right? Movement controller is all the basic stuff that handles movement. So, like, you can move, but you're not animated or anything like that. Animated controller is like movement, but it's kind of built to allow for like walking and jumping animations to just kind of, I'll show you in a bit, I'll show you in a bit. And playable controller extends animated controller further, so that way you can be playable and animatable. It's pretty cool. But to get into the basic part of it, movement controller, right? At the start, got a bunch of serialized fields, just stuff that you can define per object, right? Like if it needs to start blocked, or what the starting speed of the object is when it begins moving, as well as the speed that it gains every second, the maximum speed it can have, the strength of jumps, and how many times you can jump while airborne. Whew, that was a mouthful, y'all. Sorry, I get anxious talking a lot, so might be taking some word breaks in here. But anyway, to kind of get into it and everything, right? At the start, when the object is first called into Unity, right? It's going to basically set the lock state based on if it should start locked, find the rigid body in the collider, situate our air jumps, and it's also going to call this thing called start controller. And what that actually is, it's an abstract function, meaning it's not defined here, but in anything that extends movement controller, which right now is only animated controller, it'll define it, right? So like for this one, we're just going to prepare the animator and go further down the rabbit hole when that happens, right? So after everything gets set up, you might kind of wonder, like, how do we go about things on a frame by frame basis? And that's this monstrosity right here, this gigantic chunk of code. We're actually going to come back to this in a minute though, right? Instead, I'd like to look at check if grounded, right? So what this function does is it checks if we're grounded. And the way that it does that is it finds the bounds, right? Or the bounding box of our collision. Man, this is a subject of its own, but if you want to think about a bounding box as something, think of it as just like, honestly, let's just do this. Let's just go to scene. Let's go to my key. This green thing is like the bounding box, right? It's the limits of the object. And so when we're in here, we're going to get the object's like limits, right? And we're actually going to cast a ray cast from the center of those bounds in the direction of up times -1, which is simply down, right? And the distance of that ray cast is actually going to be the vertical size times 0.51, or just a little bit over half of the size, cast it down to see if we hit the ground, right? And if we do, result will be true. If we don't hit anything, result will be false, right? So for check if grounded, we're going to say if result, like if we did hit ground, and if we were not grounded last check, right? Because every time we check if we're grounded, grounded last check is basically stored, right? So like if we were not grounded the last time that we checked, but we are grounded now, we're going to reset the air jumps, and we're going to call a function called onLand, which only gets called when you actually land on the ground, right? When there's a frame that you hit the ground where you were not on the ground previously. My brain is starting to hurt, so I'm going to take a second before I start talking again. All right, I've returned from my break, and So basically, right, you'll notice there's a property here, is grounded, and all it does is returns that last grounded check, right? The reason we do this is every time that I check is grounded is literally every frame, right? Like rather, so let's go back to update, right? This happens every single frame. So if our controller is not locked, right? If we're not locked, we're gonna do all this stuff. If we're locked, we're just gonna skip it, right? Because you can't do anything if you're locked, right? So the first thing we do is we check if we're grounded. And when that check if grounded happens, it's gonna store the grounded last check, right? Or it's gonna update that to be the check that we just did. It's also going to next gather, well, so there's this function, right? Get movement vector. It's abstract here, right? There's no implementation, but really it's just the normalized vector. Doesn't necessarily have to be normalized, but the normalized vector representing your movement, right? So if you're moving one unit forward X or one unit forward Y or both of them at the same time, so on and so forth. And if that current movement is not nothing, right? If there is movement, then we're going to do this block. And what this is, we're checking if the current speed is 0, right? If there's no speed currently. If so, the current speed needs to be the starting speed, right? And if speed is 0 and we started moving, then we're going to call onMovementStart, which is another abstract function, or method rather. The point of it being that subclasses can tell when movement starts rather than when it's already been happening, right? You can begin an animation or things of that nature, right? Now, if the speed is not equal to 0 and we are moving, then we've been moving, right? So our speed needs to increase. And what we do for that is we actually say that the speed is going to increase by speed gain times time dot delta time, right? The easy way to say it is that this runs every single frame, and we only want speed gain to gain per second, right? So by multiplying it by this time dot delta time, it's a proportionate rate to the frame rate in the seconds that essentially just makes this gain at a speed gain per second rate, right? And we're going to clamp it between the starting speed, which is the minimum value, and the max speed, which is the max value, right? So it's always going to be between those two values, right? And then after that, regardless, if there is any movement, we're going to add that movement to the pending velocity. And we're actually, when we add it, we're going to multiply it by the current speed and the time dot delta time so that movement is continuous, right? So that it's not just jumping around depending on your frame rate. Now, if there is no movement though, right, else, then if current speed is not equal to 0, right, meaning that you were moving before, movement ends, right? So we call that same abstract function that allows other classes to know that movement has ended, right? And then we set the current speed to 0. After all of this, we go and update the controller, which functions a similar vein as our start controller function here. Now it's time to take another break before I explain more. Return again I have, and this time we're looking at protected bool jump, right? Jump is a function called by other, or I guess subclasses, right? Like this one, wherever it calls it. And when jump gets called, it basically attempts to jump, so to speak, right? And the way that that works is we basically set a boolean, right? We say, can we jump? And we're going to assume we can't jump first. Now, if we were grounded our last check, we're on the ground. So yeah, we can jump, of course. But if we weren't grounded last check, if our air jumps are greater than 0, right? If our air jumps remaining rather are greater than 0, if we can air jump, yeah, we can jump, but we're going to take away one of those air jumps, right? Air jumps remaining. Now, if we're locked, right, this is a little bit of trickery here, right? And all this is saying can jump equals can jump and not is locked, right? So if we can jump, this is going to be true. And if it's not locked, this is going to be true. So we can jump if we're already able to jump and we're not locked. If we can't already jump, doesn't matter, can't jump anyway, right? But if we can jump and we're locked, nah, we can't jump. Why would we be able to jump? We're locked, you know what I mean? So we just can't. Now, right here though, can jump, right? If you can jump, then we're going to add that jump strength to the pending velocity almost the same way, and we'll call on jump so other subclasses can know that we're jumping, right? Despite the fact that they would have called it. It's just kind of the way that I've been doing it, you know? And then we'll return can jump so we know if we were able to jump or not. Further than that, the fixed update that runs, the easy way to say it is on every physics tick, right? May or may not be in sync with frame rate, but will be at a constant rate. And so at that point, we're going to check if the pending velocity, if there is any pending velocity, we'll add it to the rigid body, and then we'll just clear out the pending velocity so it doesn't continuously go through and do that, right? And then we have a property for isLocked where it can only be set publicly. And when that happens, if we're actually locking it, it calls this onlock abstract function so that other features can know. So this is kind of the general like structure of movement controller. We go a little deeper. We go into animated controller, right? And this is where things start coming together. So to actually show you though, in my animator, this is the player's animator or the person animator, right? And the idea, there's a boolean for is walking or is jumping. You're typically in the idle state. If is walking, you're walking. If is jumping, you're jumping, right? It's that simple. And so when we go in here, for the animator controls, I'll actually show you on the person. The walkable name is walking, is jumping. So they match the animator basically. And what happens is we actually maintain states in here for if we're walking or if we're jumping. On the start controller, which is called, as we saw on start here, the animator is set up, and we also call on animator setup kind of in the same vein, so that way playable controller can see that things are being set up, right? There's a protected bool for walk. It's a property for walking, right? If you're getting it, it's just going to tell you walking, same for jumping. But if you're actually setting it, we're going to set the value, and we're also going to set the bool based on the name and the state, right? So that's where it keeps things in sync. Now, this is where we get to see the fun stuff with the on movement start and on movement end, right? If your movement starts, you're walking, and we're going to pass it through to on walk start, same premise. Same thing here. If movement ends, you're no longer walking, we're going to go on walk end, right? Now, here's on jump, similar kind of thing. Jumping becomes true, and on jump start, so we can kind of pass it through further. And then when you're landing, right, on the grounded check, if you weren't grounded the previous frame or the previous check, but you are grounded now, then we're going to basically see if you were jumping to get into that state, set jumping to false, and if you previously jumped into that landing state, then jump ends, right? So it just kind of pushes through further. Now, whenever the character gets locked though, we also need to set the walking and jumping states to false, so that way the animated person isn't just like walking like in place while they're being locked, if that makes sense. And then we just kind of pass it through further. So now this is where everything comes together, coagulates, and becomes playable. So we're going to extend animated controller a little bit. And man, hold up. I'm going to take another break. My head's starting to hurt again. Sheesh. All right, we are back. So I'll kind of have to show you guys real quick in the Unity scene the way that the person is structured. So we actually have a person handle and we have a camera handle, right? And like, let's say we rotate just the camera handle, right? The camera rotates, but not the person. Okay, let's say we rotate the person handle, right? The person rotates, but not the camera. And this is very important for our camera and our player to work in sync. And so what we do here, we've got a field for camera sensitivity. That's pretty important, but we actually keep track of the transform of the camera handle and the person handle, as well as the default camera rotation, and we'll get into this in a minute. Now, this is something known as a debounce to make sure that if you're holding the jump button, you're not just going to continuously use all of your air jumps like in consecutive frames, right? So it actually just makes sure that you can't hold the jump button to jump, 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 jump until you run out of jumps immediately, right? So when the animator's set up from animated controller, we're going to just get the person handle, get the camera handle, and save the default rotation for the camera, right? And then every frame on update controller, if you're not pressing jump, then we just keep track that you've unpressed jump for at least one frame. And then if you're trying to press jump and have unpressed jump for at least one frame, then has unpressed jump is equal to not jump, which looks weird if you're looking at it, right? But remember, the jump function returns true if you can jump and false if you cannot jump, right? So if it returns false if you could not jump anyway, then has unpressed jump is going to be true because you didn't get to jump anyway. So why would we take your unpressed, so to speak, right? It's just a little bit of trickery. But then this is the part that actually moves the camera. And you're going to see camera handle transform dot rotate 0 on the X, 0 on the Z. But on the Y axis, the one we were manipulating earlier, we're actually going to rotate it by the mouse X movement times time.delta time to make sure it's at a constant rate, times the camera sensitivity to actually make that change things, right? And then, yeah, that's pretty much what happens every frame. You'll see I don't really use these. They're cool to have. I might use them later. We'll go over get movement vector in a minute because it's very important. Reset camera, and all right, cool. So before I hit get movement vector, we're going to talk about the reset camera coroutine. And actually, I don't think I use that currently. I might put it in soon. But basically what happens is whenever, let's say you call reset camera the first time, right? The first time there is no current reset coroutine. It's null, so this skips, right? But the current reset coroutine is then set to a new coroutine started from this function right here, right? And so what this does, it just takes the rotation of the quaternion, or man, we just went real deep there for a minute. It just takes the current rotation of the camera from when you start resetting, and it basically just does a lerp, or a linear interpretation, or interpolation, I should say, between the current camera state and the original one. This is kind of complicated for me to explain at 11:11 p.m. on 11/11/2024, so I'm just not going to right now, but I don't even use it anyway, so just ignore it. But for get movement vector, right, we're going to create a vector 3 of normalized input. It's going to be input on the horizontal axis and the vertical axis. If it's not equal to 0, then we actually, we'll jump back to this in a minute basically, but we're just going to return whatever comes out of this, right? Actually, we're not jumping back to it in a minute because there's nothing to go to instead. So here's what happens, right? If there is movement, the movement is multiplied towards the look rotation of the camera, right? Sounds like it makes no sense, but here's what that actually is. Basically, we're taking the direction that the camera handle transform is facing in, right? The forward direction of that. And we're actually multiplying the movement based on that because that rotates it to where the movement faces that direction. This took me a minute to figure out. I don't fully understand quaternion still. It may be obvious, but that's basically how we do that, right? And then afterwards, we set the transform of the person handle to the direction you're moving in. And what the function of that is it actually makes the person face the direction they're moving in, right? So this one orients the movement based on the camera, and this one orients the person based on the movement, right? So it looks like they're actually walking in the right direction. Whew, man. But that's the general premise of how this code all works and forms, this thing. So you'll see, like, come on, complete the domain. You can do it. We didn't even change anything. So like right now, I'm just moving forward, right? Or forward and right, but now I'm just moving forward. And see, the transform.forward of the person being updated is what causes them to actually rotate here. And when I change the camera, like this is me moving forward again, because it's actually multiplying that forward times the direction the camera is facing in. So yeah, that's kind of how this all works. I don't know if I showed you all the messages here. You need a key to unlock it because we're cool. That's our double jump. We can only do one double jump so far. Door is locked from the other side because we're balling. Then we got the key. No more key needed. Boom. Door opens, door opens, door opens, door opens. Based. But anyway, I appreciate y'all's time, and surely I'll see y'all again soon. See ya.